Moving forward, we have another speaker with us, Shree Kumar, who will be speaking about open source in and for Indian chips. Shree is a software developer and a FOSS enthusiast. He is the best known for Kite Phone, a DIY 3D printable open hardware smartphone concept. Shree is a generalist with considerable experience in embedded systems, high performance computing, and computer graphics. Recently, he has been exploring the intersection of technology and policy. Today, in his talk, he'll be showing how an open source approach can benefit Indian players. So, the stage is all yours, Shree. Give it a huge round of applause for Shree. Thank you.
Hello everybody and welcome to this talk, open source in and for Indian chips. And so basically this is what we'll be talking about, right? So we'll be talking about what the ecosystem of the chips is looking like right now, how open source can help, and what I have been doing. So of course it's a large thing to get open source around chips and maybe in chips. So this barely scratches the surface of that. So quick introduction. So I'm mostly a software guy giving a hardware talk here, right? I've been doing hardware for quite a while, more than a decade, professionally. I was a designer. I was a software architect for the first 3G smartphone, 3G tablet in India, for example. So I've been doing this for quite a while, and various devices like phones, trackers, various things. But before that, I was into high performance computing. So I'm from the Y2K batch of engineering. So I've done a fair bit of things here and there, but I think I've settled mostly on embedded systems and these kind of things. Beyond that, I call myself a hardware designer in the sense that while I may not do the nitty-gritty of everything in hardware, I design things at an overall level. I specialize in all things 3D. So what does that mean? So various things, right? So I wanted to be a game programmer at some time. There's a long history between me and 3D graphics, and you'll find that my handle on all social media is Shree Kumar 3D. And probably one of the best examples, and what I'm best known for, is probably this project on Hackaday called Kite Phone. It's the most followed, but not the most funded project there. So as hobbies, I have cycling and fooding. So cycling, I probably cycled about 70% of India. I may not look like it right now, right? And fooding is not a syntax error. It's basically how they write about various places in the Northeast. And I'm also a fractional volunteer and policy wonk. So I volunteer here and there. I help organize bar camps sometimes. And the policy guys, they like the fancy words like wonk. All right, so quickly running into this talk, why do we need open source hardware, right? So why do we need open source in hardware? So let me start off with a disclaimer. Hardware will have, and I think this will be true for a reasonable amount of time still, commercial grade hardware will have a proprietary angle. So that out of the way, so let's get into the context. So electronics hardware, if you have noticed in newspapers and government incentives and so on, is a national priority. It has been for a while, and eye-popping numbers are being thrown by the government into building an electronics ecosystem in India, right? If you now go and take a round of the booths, you will see how little of hardware exists. And let's not forget that something like Silicon Valley is not about software actually originally, right? It originated because of silicon, right? So now what we are trying to do is replicate things. So we have various priorities. These are national priorities at this time, mostly skill development, ecosystem and community development, because it's not just like some people will build it. It requires a whole lot of effort, a lot of people who need to be involved to actually get this off the ground, right? And accelerate development and innovation. These are all the areas where open source hardware can help. We already know this. We have seen this for like decades in software already, right? So open source in hardware will has a potential to do the similar thing in hardware, especially for India. So in India, it's always in a nascent stage right now. So that's what we are trying to do. And finally, this comes down to the skill development. It can help achieve transparency in costs, which is very important to get people interested and on board. Right. So now let's come to one of the important things which has been happening around, which is RISC-V. Various people have called it Linux for chips, right? RISC-V is an ISA, open standard. It's like a machine language which is standardized and it's royalty free. So you can build new chips using RISC-V and you don't have to pay anybody a royalty or a design fee, right? And it's scalable across all levels of compute. That means you can use it all the way from tiny microcontrollers all the way till supercomputers. This is achieved using the extension mechanism, and there are multiple proprietary open source and proprietary implementations. And there's a compatibility mechanism so that not everybody dances to their own tunes, right? And they have achieved geopolitical neutrality by having a HQ in Switzerland. And this was a decision which was taken much before the China-US geopolitical war kind of blew up in terms of technology, right? All the sanctions and everything. Before a lot of it really blew up in everybody's face, this decision was taken in anticipation of that, right? And RISC-V is a true disruptor. It's a true disruptive technology. I see this word being abused everywhere. Everything is being called a disruptor. Actually, no, that's not true, right? So there's a very specific definition of what is a disruptive technology by Professor Clayton Christensen. He's a celebrated Harvard, I think, business guy, right? And I much admire him. And basically, disruptive technology is something which starts as a low cost at the low end, and then it grows up the value chain. You should look this up because it's fascinating stuff. It happens everywhere, across industries, across timelines. It has repeated over and over again in history, and RISC-V is a living embodiment again that this is going to happen again. So RISC-V is already shipping as we speak on billions of devices. We may not see them because they are all in the tiny microcontrollers, but it's now in, for example, the Librem the framework laptop and such things, and soon it will be much more visible in consumer technology, right? And basically, what do I call it? One ISA to rule them all. And it will be the realization of, that old Java saying, I don't know if you guys remember, compile once, run everywhere, or compile once. We used to joke about it as compile once and debug everywhere, right? So the same thing might happen for ISA, through ISAs for RISC-V. All right, so the title of the talk was for Indian chips. So which chips are you talking about? Are there even chips which are made in India, right? So surprisingly, the government makes one called Tejas 32, and it's designed by CDAC in Thiruvananthapuram. It's available to everybody. You can buy one single chip on hobbyist websites. It's based on RISC-V, and it's 100% publicly funded. It's run by CDAC, right? And then there are also private companies, startups, which have been incentivized by the government. Primarily, the one which is right now at the front of it is a company called Mindgrove, with Secure IoT is the name of the SOC. It's not available to everybody, they're just coming out, but it's all based on RISC-V again. So if you can see, Shakti is the open source implementation by IIT Madras. And similarly, there's Netra Semi, again, that's not available, it's not even announced. But the key thing is right now, if you want a Indian silicon, which is like RISC-V, what's your choice really? Sarkaari SOC, right? So, so here's the fun thing, right? So I have a bit of public policy angle. So what happens when government gets into chips, right? So basically, we have these three big actors in the world like Sarkar, Samaj, and Bazaar, right? And here the Sarkar is trying to do what the Bazaar does. Who builds chips? Typically the private companies, right? So when the Sarkar tries to do something that the Bazaar does, the result is actually bizarre, right? What's bizarre? It's strange, peculiar, odd, funny, curious, offbeat, outlandish, right? Now, Tejas 32, my favorite Sarkari SOC, favorite and only, is actually a bizarre chip, and I've written a lot about it. I mean, there's not too much to write, but one single article would suffice, which I've done. You'll find it online. It's a 32-bit microcontroller from CDAC Thiruvananthapuram, designed by them, 100 megahertz, 32-bit, ET1031 core. That's what they've called it. I don't know. It has an underwhelming feature set. I won't go into the details. The details are available online. I have compared it against various things. Actually, there's not much to compare, but yet I have undercovered various things about it. And it has all the makings of something that is not a commercial chip. That is like, yeah, you can say, yes, we made a chip, right? Yes, we can do it. But the question is, can people who want to use it commercially use it? Answer is no, right? So various reasons for it. It has high power consumption. It's built on an old process. I mean, some of these are, it's not something that you can blame the government for. That's about it. So it has high cost, right? The chip is very expensive. You will see that later. And if you use this, even by mistake, if you use this in a design, you will end up with a board which actually costs much more money because it doesn't integrate various things inside it, right? Again, so when I saw this fancy looking name ET1031, I was like, really impressed. What, ET? Right? This is what I pictured in my mind, right? Extraterrestrial, wow, right? But what did we actually get? I had actually music, but I kind of forgot about it. What we actually got was this, right? Jadoo, right? Right? So it's like that bizarre. So I don't know how many of you have seen this movie, right? That's why I wanted to play the music for a bit of suspense, but kind of forgot it, right? So, so what kind of ecosystem? So you just don't build a chip, right? You have to build an ecosystem. You have to find buyers. They have to build applications. So what kind of an ecosystem have these guys been able to build, right? So it's just a summary. So they sell what is known as the Aries developer boards online on Robu and Amazon, but if you see, they're more closed source. I mean, they don't have much source, and even they're worse than commercial vendors, right? And the proof is in you see the number of people who are buying, the number of reviews. On Amazon, there is no review on any of those products, if you notice. And on Robu also, which is a popular hobbyist buying place, hardly anything, right? And if you ask documentation, they're like, what documentation, right? Here, take this 12-page PDF, right? Which is what they call the data sheet. And naturally, it is minuscule community, and it's like a government beating their own drum, right? So, and they do phone call support, by the way, very interesting. If you call them, I have a number. If you want, I can give that to you. They won't respond an email, the mailing list is dead, all that, but phone call, yes, right? So, great in some ways. So now, how are we trying to fix this, right? So CDAC already made it, they're popularizing it in education, but it's kind of a board which is very hard to use because there's no real skill development which is happening. So one of the things with all these kind of government, this thing is that, see, if a government spends money on a particular initiative, especially in technology, there has to be a lot of what is known as knowledge diffusion. So the knowledge has to diffuse to society. It has to bring something into the table that justifies that the government is spending the money, right? And what the Tejas 32 and the Aries boards are an example of what is not happening. The knowledge diffusion is not happening. So the way I am trying to fix it is using this thing called, this board which I have called, design which I have called it AtiVEGA, right? So it's an open hardware system to study RISC-V. So it doesn't claim to do, things like, yes, you can do the regular stuff with it, we'll come to that, right? So it's an open hardware system. You can find it on GitHub, the entire hardware, the software also. It's work in progress right now, right? And it has been produced very recently. So you can see a real versus real. So this is real in hand. We'll see a demo soon. And it gives you, the common things that any developer board will give you. It allows you to plug in Raspberry Pi hats. It has GPIOs, it has SPI, I2C UART, and it also includes a Pico. Right? A Raspberry Pi Pico is a very popular microcontroller. So this is a board where you get 2 microcontrollers in one board, both of them programmable. Right? So how is this board different, right? What is the USP? Why should I build it? So I spent half of my talk trashing that sarkaari sock, right? And now I say like, here I have built a board. So what's the method to the madness, right? So see, as bad as that chip is, I mean for commercial applications, it has some goodness to it. It has some real use case. It can really be deployed in education, right? And that's what this board tries to target. So this is the only chip that you will find in the market where you can directly control the clock. So the clock is what runs the whole entire show, right? The speed of the clock runs the entire show. So this allows you to directly sitting outside the chip, you can control the clock. And that is the differentiator of this board. And we combine this board, which has almost no community, with a board, which is a Raspberry Pi Pico, which has a massive community, right? And the Pico 2 is, of course, already come. And that will, of course, increase the whole thing. So here you can directly control the, if you see, you can directly control the clock of the Tejas 32 And this is something that no microcontroller in the world will allow you to do, for very good technical reasons, but this one does allow you, and that allows you to do very interesting things, right? So now, so what can you do with this board? You can do the typical things. You can connect sensors, displays, I2C, UART, SPI, anything, you know, a typical Arduino thing that you do, like anywhere from kids to like engineering students do. All of that is possible, but you can go much beyond that because of that clock control that I am talking about, right? So you can deep dive one into the ISA implementation. I'll give you some example a little later. You can characterize silicon's power consumption. You can actually reverse engineer Tejas 32. Of course, Tejas 32 is a reverse black box kind of thing because there's not much of documentation. And if you're brave enough, you can assemble from first principles. It doesn't require a lot of skill. So the board schematics available. You can actually get PCBs made in as little as 3,500 rupees, I think, if you have 15 days to spare, and soldering is not that difficult. So you can build competencies at various levels, and these are critical to helping build the ecosystem, right? And typically when you make something, right, people ask you how much it costs, so I thought I'll put some, everything is open source, so I did the math, and right now when I build 10 boards, it probably cost me about 10,000-12,000 rupees. So, and here's the interesting thing, right? So I pointed out there. So the Tejas 32, just the microcontroller, costs just a little fraction less than the Raspberry Pi Pico, which is the entire development board which you saw in green. And that's a comparison between the Sarkaari sock and the Bazari board, right? Right. So let's go to the demo. Just give me a while I set this up. So in this demo, we will do overclocking. So Tejas has a few boards that you have seen already, right? They're all made by CDAC, and so the thing there is that they advertise it as a 100 megahertz board, correct? And if you have been seeing the hobbyist interest around the RP2040, you know that people are not really happy with running the processors at stock speeds. They want to run it much higher. So I've been able to run the Tejas 32 at about 150 megahertz reasonably consistently. And you know, this is not something that anybody else I know has done, so I thought I will show it on stage. Oops. Okay, so here's the board, which you can see, right? Oh, I am very sorry. I made one mistake. So here's the board that you can see. So there are basically two LEDs if you look at it. So the board is, you can see the board, right? So, so there are two LEDs. One is that green blinking LED is a LED which is being blinked indirectly by a signal which is coming from the Tejas. So the Tejas is basically toggling a GPIO pin line, which is typically how you blink LED, right? You set the pin high, you set the pin low, right? Oh, actually, I'm sorry. It's sending a message on UART. And based on that UART message, that green LED is blinking. And the red LED is a very unique feature of Tejas. So they have, you know, they are like, they made debugging the lifeline of this chip, which is like highly unusual for a board. So they have a heartbeat LED, which basically like is like ultimate hardware debugger's dream. Like they possibly have a counter where based on which the LED is toggling, right? And it's a pure hardware thing. And so right now the board is running at 100 megahertz. Now what I am going to do is, sorry for that. I am going to overclock the chip. I will show you how. So I'm going to overclock the chip to 150 megahertz. You can see here sys clock hertz. So it's this Raspberry Pi Pico, if you probably are familiar, it's a CSDK. And in the CSDK, you can set the clock speed, right? And then I'm going to build build the board's code, and come on, man, build, yes. Then I'm going to copy this thing to the Pico, which is what they typically do, and you can't see this because I'm doing it with my hands. So basically, I send the Pico to the bootloader mode, connect it, and then it's copied, and all right, come on. So it started blinking again, but I don't know if you can notice it, the blink is much faster, and there's no other proof that I can provide right now, right? Oops. Oh yeah. I'm sorry, I didn't realize that. Yeah, oops, I didn't notice that. Sorry. So the blink is going to be much more fast compared to that. I can't provide any other proof. Can't get an oscilloscope representation, right? So it's much faster. So it's right now running at 150 megahertz. You can actually go much faster. So here's the fun part. So I'll go like just a little faster because this is quite instructive. Just too many things here to do. Sorry for that. Right, so I'm going to make it 180 megahertz. Build it again. And copy it. You can't see this part because I'm doing this here. So once I copy it and it goes there, then I run it and let's see what happens, right? So you now see only the red LED blinking, right? And the green LED is not blinking. So that means actually the Tejas is dead or alive. So the heartbeat says that it is blinking. That means Tejas zinda hai, right? Maybe about to die, right? So we don't know. So there are a lot of mysteries still to be solved about this. But 150 megahertz is about the sweet spot for this chip as far as I have seen. I've gone. So there's something called silicon lottery. Don't get excited. CDAC is not giving a lottery with everybody, right? So basically, some chips I've seen can go as high as 172 megahertz. The behavior is very inconsistent. So so don't bet on the silicon lottery to shore up your fortunes. All right. Now coming back to the presentation very quickly. I hope that demo was clear. I just made some attempts here, right? So that might be a fancy thing doing the overclock, but what's the new way to? This is a new way to understand basically silicon. So like you do Verilog simulation, right? I don't know how many people are familiar with it. Something that chip designers use. Building silicon is very expensive, so they do a lot of simulation. In the simulation, typically one of the most important things is that they control the clock directly, right? And then they will look at the output of the simulation and they will match it against predetermined outputs. So, okay. But in this chip, you can actually control the clock as a GPIO. So that means that you can actually you can just use the GPIO, you can pull it high, low and everything, and then based on that it will, you can actually study the behavior of the chip at an instruction by instruction or a sub-instruction level. So remember, there is a 3 pipeline decode, execute, fetch, decode, execute kind of microcontroller. So you can, go very deep. And for people who want more details, just contact me offline. I'm running out of time here. So current status, we have version 1.0 hardware, 4 boards we have already assembled. Most features are validated. There's a project page on Hackaday, and GitHub repository is updated real time with samples. Where do we want to go? Actually, next steps is what it's supposed to be. So coming soon, so we're going to have beautiful documentation. So we just made some beginning. We want to have a SDK, a modern tool chain kind of thing, modern tooling. Please follow the project for updates. If you want to try the board, buy or whatever else it is, you just let me know. And so the summary, So open source hardware, I think, is crucial for developing the Indian semiconductor ecosystem. We need many more such efforts. That's my opinion. Open source hardware can build deeper capabilities, enable new use cases. That's a fact. And I would like to see CDAC open sourcing ET1031, just the CPU core, if nothing else, right? And I would want to see more open hardware for vendors. That's my hope. And there's a reason for this hope. So the Raspberry Pi came up with RP2350, their latest chip, and that has a fully open RISC-V core, including the development history. And you can actually buy it now. I mean, I have mine on pre-order. It's a little late coming in India, but you can buy it now. And if a private company can take their core and make it open source and put it in the chip, the real one, why can't a government one do it? So it will really help this ecosystem, right? And quick pitch. So there's a free hardware library that I'm trying to set up. Please help me. Free as in free lunch. Please contact with me offline. And thank you. Any questions will be offline. We are out of time. Oh, do we have time for questions?
Yeah, we can take one.
Oh, no, not to pressure you. Any questions?
Sir, is the plan to make this into like a like a complete dev board type thing where people can buy and use this to learn, play around and learn with like learn capabilities around Tejas or and we know just RISC-V in general? Is that the plan?
They can do Tejas.
Okay.
And they can do RISC-V. So due to that clock control, especially that's the USP of this board. You can actually look at instruction execution at an instruction by instruction level, which is otherwise not possible in any other chip. And that's a great way to learn architecture and whatnot. A lot of things. You can do single stepping. You can do debuggers. It's very
How do is there any? Are you going to set up a store or something for this, sir?
I might do some crowdfunding after a while.
Okay.
So of course, if I get a foreign market, I guess I'll have to see, because the larger buyers, if history has anything to go by, is probably the export market. I don't know how the export market will see this. Sarkaari sock.
Okay. Thank you, sir.
That's all, I guess. Any questions offline? Thank you. Thanks a lot.